All right, so scatter plots and predictions. We're going to start with trend lines. When scatter plots demonstrate a linear relationship, a trend line can be used to show the association between the two sets of data. The equation of the trend line or line of best fit can be used to make predictions or estimate solutions for a data. I will let you know that not everybody's is going to be exactly the same. You have to pick something that's pretty darn close, especially if you have answer choices. But I will say, when in doubt, graph it out as well, because you can get a more solid answer for that. So here we have a tomato farmer, and he monitors the number of bees that visit his garden in the spring and the number of tomatoes he harvests in the summer. His data from the past 10 years is shown in the table below. So because I have a table of data, I would actually, when in doubt, graph it out. So we're going to create this scatter plot off to the right here. So I'm going to go do that real quick. All right, so there's all of my data and it's plotted. I think it did a pretty okay job. It may not be perfect, but it gives you an idea of where everything should be. We're going to use a straight edge and we're going to graft a trend line through it. So kind of want to hit the middle of the data. Not a great line there because it doesn't go through the origin. So let's see here. A little bit more like that. There we go. All right, so now that I've got my trend line, we're going to pick 2 points on my trend line to write an equation, which is going to be that y equals mx plus b. So I think that it crosses the y-axis, so my b right here at about 8, so plus 8. And so I'm going to let that be 1 point, the point 0.08, and then another perfect point that I can kind of find is the point 30, 40, but I kind of want to pick something a little bit higher, so we're going to go with that one, 60, 80. With that point 60, 80, I can then go through and do my slope formula. So when in doubt, graph it out. I can plug that information in. And for my slope, when I do that, I get 6/5, and I plug it into my equation. Now, my equation is not necessarily correct compared to someone else's equation. So just keep that in mind. This is a trend line, so it's an approximation. So what I'm going to do is, how could this equation be used to make predictions for the farmer's garden in the future? And this is where you can plug x or y values to solve the other variables. So we can plug things in and get a solution. And it's not going to be exact. It's going to be pretty darn close because, again, it's indeed a prediction. All right, so trend lines can also be found using a graphing calculator. You're going to input the data from the tomato farmer into your graphing calculator and find the equation of the trend line. How does it compare to yours in C? So I would do exactly what I would normally do. When in doubt, graph it out. I would make my table. After I make my table, I would input y1 tilde mx1 plus b and see what you get. The graphing calculator gives you y equals 1.37x, and that is rounded, plus 5.47. Again, that's also rounded. The slope of the estimated line is close to the calculator line, and the y-intercept is lower than the calculator line. So again, there's a lot of estimates because it's a prediction. So here we have Stewart estimated y equals 5x plus 20 as an equation for the scatter plot for the trend line. Is this reasonable? Well, if I was to draw a line through this, and I sort of did okay, I would say no, it's not reasonable. And the biggest reason why it's not reasonable is because he gave a positive slope, and this is a negative trend line. And that would make it not work. So the slope is negative. This is why it's so important to know by just looking positive, negative, 0, undefined, increasing, and decreasing. So how many in-store customers would you predict if there were 18 curbside orders placed? So curbside orders, there's 18, so I'm going to go to where 18 is, and I'm going to draw a line up. So approximately, I get about 100. But again, that's a little bit over, so maybe I might even want to go as far as saying like maybe 110, just because my line's not perfect. I could have shifted that line up a little bit more and got a different answer. So not everybody's is going to be exactly the same, and that's okay. Keeping in mind, when in doubt, to graph it out, we have someone that is studying snakes, and they affect the temperature of the snake activity. The chart shows temperatures and the hours of activity of a snake on a different day of the year. A linear function can be used to model this. So when in doubt, graph it out. It wants us to use the calculator. You're probably going to have to use decimals, and that's completely okay. Just round it to the hundredths. So in this one, when I do graph it out, I get y equals 0.25x minus 5.79. Again, when in doubt, graph it out. If the temperature is 40, how many hours of the day will the snake be active? Well, this is where I would plug it in. And so that would be y equals 0.25. We're going to multiply by 40 because that's going to be our x. These are our x's and our y's. And since we're talking about temperature, it's an x. And then we're going to subtract 5.79. And then we are going to get a solution for this, and it's about 4.21 hours. If the snake has been active for 9.5 hours, so keep in mind here the 9.5 is hours and hours is a y. So then what I'm going to do is I'm going to plug it in. We've got that 9.5 for the hours, and that is equal to 0.25x minus 5.79. This is where I would do my inverse operations. So draw my line, add 5.79, and then divide by 0.25, and I get about 61.2 degrees. Find the correlation of the coefficient and describe the association. Again, we're looking for correlation coefficient. That's going to be R equals. When in doubt, graph it out. And so our R is equal to 0.96, which means it's positive, close to 1, which means it's strong. And so the data has a strong positive linear association. So remembering that little table from the last set of notes. And again, when in doubt, graph it out. So that's going to be key here. All right, here we have the graph and table show the results of survey asking a person's age and the number of online purchases they make in a week. A linear function can be used to model the data. So what is the best prediction of the number of purchases a 30-year-old would make, round to the nearest hundredth? So if I was going to make a prediction of 30-year-old, I can see that this is a close age. This is a close age, anywhere between 14 and 10, so I'm going to say 12 purchases. And if I was to draw a line through my data, if the age is 30, I'm going to look up and see, it's pretty darn close to 12 right there. So I think 12 is a good estimate for that. If a person made online purchases a week, 3 online purchases a week, how old would that person be? So I'm going to come over here and I'm going to look to about 3 on my graph. Their age, pretty darn close to 60, but not quite 60. I'm also going to look here and here, so anywhere between 50 and 64. So I'm going to say about 59 years of age. Again, it's a prediction. You can guesstimate what you think it is. Now, which function could be best to model from the ages of 20 to 25? You're going to say, when in doubt, graph it out. And so as you can see here, I've circled the ages between 20 and and 55. I'm going to take this one out because that's not part of our data set. And when in doubt, graph it out, I get that the slope becomes negative, so there's less purchases over time, and there would be a causation there. As they got older, there was less purchases over time. All right, so a children's museum reports the number of visitors in a month compared to the number of rainy days in the month. The relationship can be modeled below. When in doubt, graph it out. If there were 5 rainy days in a month, how many visitors should the museum expect that month? Well, I'm going to look at what's closest to 5. Again, when in doubt, graph it out. So there's 3 and 7. So I would say 5 would be anywhere between 223, well, and we could also say 9 because that seems kind of close too. So anywhere between 223, 187, and 221. Because of that 9-day one, I'm going to go with about 197 visitors. Again, there's a lot of things you could have put on this, so just keep that in mind. There's a lot of potential answers. You could have even said, I could have even gone with 210. I would have expect anything in that area. Find the correlation coefficient and describe the association. When in doubt, graph it out, and you find that R is equal to 0.82. That is a positive association, close to 1, which means it's strong. So there's a strong positive linear association. And I want to keep in mind that when in doubt, graph it out here. Especially with that correlation coefficient, that's going to be really important for you guys. All right, if you have any questions, please let me know.